Hi everybody, welcome to this video. In this video, we're going to be covering the topic of elasticity of demand. So this is a big topic in applied calculus. So let's go ahead and read some definitions of elasticity. So when a change in one variable causes a response in another variable, elasticity is a measure of the size of the response. So what elasticity is just measuring the response to this change of that variable. So elasticity measures how sensitive that value of one variable is to the value of the other. So if a percent change in the input variable causes a relatively large change in the output variable, the relationship is known to be elastic. Okay, so if it causes a large change, it's elastic. And if a percent change in the input variable causes a small change in the output variable, then the relationship is inelastic. So small change means it's inelastic relationship. Okay, so let's go ahead and be able to find this elasticity, right? So point elasticity of demand. So the point elasticity of demand is denoted by this little Greek letter, looks like an E, but it's called epsilon. Okay, so it looks like a little, looks like a little E, but it's a Greek letter epsilon, which is a popular mathematical variable. If this is your first time seeing it, but it's defined mathematically as epsilon equals negative P over Q times a derivative of Q with respect to P. Okay, so this is the formula, right? And don't worry, we're going to be able to calculate all of these values, right? This is one value, this is two values, this is one value altogether. We're, through the process, we're going to be able to find these values, calculate them, and then just throw them all together and be able to get that point of elasticity. Okay, so let's go ahead and read what each thing means though. So Q is a original quantity demanded when the original price per unit is P. So Q is quantity. Q is quantity demanded, and P is price per unit. Okay. So point elasticity measures the elasticity at a particular point and is interpreted as the percent change in the demand for a 1% change in price. So you're increasing it 1% and you're trying to see what the elasticity of that relationship is. But okay, so that's the setup. And here's a little graph in case this might help. So as price per unit increases, what's the relationship is the quantity demanded. So in kind of layman's terms, what is this graph saying? So if you raise a price, would it affect if it is, let me write that, if it is being bought? So that's really the big question about elasticity. If you raise a price, say this 1%, is it going to affect it being bought? People are people not going to buy it? Are people going to buy more? Things like that. So let's go ahead and check out a few questions about these. So before we even do, let's go ahead and get some parameters about elasticity. Okay, so this first part, right? If epsilon is greater than one, right, we're going to get a numerical value for epsilon. If it's greater than one, then that means the demand is elastic. So what this means is revenue decreases with that price increase. Okay, so if demand is elastic, revenue decreases with price increase. If epsilon is less than one, if it was like 0.4 or something like that, that means the revenue increases with price increase. And so what if epsilon actually equals one, right? What if our elasticity, point of elasticity is just one? That means the demand is unit elastic, and that means that the revenue, it's neither increasing or decreasing. It is unaffected by price increase. Okay, so that is our setup with elasticity. So let's go ahead and check out a couple of these examples, right? So for our particular commodity, the demand function is Q. It always will be a function of Q. Q equals -2/5 P plus 10. We want to find the point of elasticity when P equals 20, when the price is 20. You want to know, is the demand elastic, inelastic, or unit elastic? And one other thing I want to add into this as like a part C is interpretation. Okay, so that's one thing I want to be able to add into this, right? So let's go ahead and check out part 2A. So remember that our point of elasticity formula is this guy right here. And one thing I want to change here is maybe not rewrite it as dq over dp. I want to rewrite this as really just q prime, just to make it a little easier on us. So here, right, remember that rewriting that is negative p over q times q prime. Okay, so let's go ahead and check out letter 2A and see what exactly. Let me write interpretation there. But let's go ahead and see exactly how to find the point elasticity when P equals 20. So 2A, right? Let me write it right here. So 2A, we want to first find Q. All right, I need to find that numerical value Q so I could plug it in there. So Q given to me is Q equals -2/5 P plus 10. And I know that P equals 20, so I'm going to just plug in 20 into here. So I'll have Q equals -2/5 times 20 plus 10. And this ends up becoming -40/5 plus 10. And that's -40 divided by 5 is -8 plus 10. And that just equals 2. So Q equals 2. Okay, great. So I have the Q value now, right? I have Q, I have P already. They gave it to me. Now I need to find a numerical value Q prime. So Q prime, right? That means a derivative of Q. So what I'm going to do is just take this Q function and just take the derivative of that. So let me go ahead and write that out. So I'll say now find Q prime. That's my next step. So I just have Q, just going to rewrite the function here. -2/5 P plus 10. And I'm just going to take the derivative of this. So Q prime. Remember, P is like our variable here, as if it was just X, right? So kind of treat it as such. So that means this goes away and the 10 is a constant, so that goes away. So this just becomes 2/5. So now I know my Q prime. So I know this guy now, Q prime. So now let's go ahead and put this all together in this formula. So let me go ahead and write that out. So I'll say here, now find the point elasticity epsilon. So remember, epsilon equals negative P over Q times Q prime. And let's go ahead and plug in all the things we have. So epsilon equals negative P. Remember, P was 20. Also have it here as well. So this is negative 20 over Q. I found Q to be 2 right here. So over 2 times Q prime, which is negative 2/5. Okay, so this ends up being negative 40. Sorry, it should be positive. Two negatives make a positive. Should be 40 over 10, which is just 4. Okay, so I have my point of elasticity is 4. So that's it for part A. I just need to find the point of elasticity. Second question is the demand elastic, inelastic, or unit elastic? So come up here, part 2B. So since, right, we found it, our point of elasticity to be 4, so I'll say since epsilon equals 4, and that is greater than 1, what does that mean about our elasticity? If it's greater than 1, then the demand is elastic. So since epsilon equals 4 is greater than 1, then the demand is elastic. Okay, so we have an elastic demand. So what does that mean in terms of an interpretation, right? We want to interpret what this means. So what I'll say here is coming off of this 1% change in price, right? Some type of interpretation. What I'll say here, this is kind of copy and paste for these questions, is that since elastic, if the price is increased by 1%, the demand will decrease by this epsilon that you found, this point of elasticity, that percentage. So decrease by 4%, and the revenue will, what happens to the revenue? It decreases. And the revenue will, oops, will decrease. Okay. So that's it for part C and question 2 overall. Okay, so let's go ahead and check out question 3 now and do the same process. Although this is a little bit of a scarier looking function, but once again, we will just deal with it as normally. So let's go ahead and start a new page and work on number 3. So number 3 says for a particular commodity, the demand function is Q equals 5,000 over P squared to the 5th root. And we want to find the point of elasticity when P equals 32. So a scarier looking function than before, but we still need to take the derivative and things like that, right? So same process, just different function. So same thing, I want to first find Q, right? That's my first thing I got to do. So what I want to do here is just plug in P equals 32 into the function, right? When P equals 32. So I want to rewrite this a little bit so it's easier to plug in our calculator. So I'm going to rewrite Q equals 5,000 over P to the square to the fifth root. I want to rewrite this as Q equals 5,000 over P to the 2/5. It's just easier to put in our calculator. So if I'm going to plug in P equals 32, right? That means I'll have Q equals 5,000 over 32 to the 2/5. Okay, so in your calculator, put in 32 to the 2/5. And this is going to be 5,000 over 4. Okay, and 5,000 divided by 4 is 1,250. So that means Q equals 1,250. Okay, so now we found Q. We know what P is, so now our next goal is to find Q prime, right? We need to find a numerical value. So next step, now find Q prime. So once again, I have Q equals 5,000 over P to the 2/5. And I want to rewrite this so I can use a power rule. So I want to bring this guy up here. It's going to make it P to the negative 2/5. The exponent becomes negative. So what I'm going to say here is rewrite Q to equal 5,000 Q to the negative 2/5. Right, I brought this guy up, makes the exponent negative. Okay, so I need to take a derivative of this now. And so this becomes Q prime equals 5,000 times negative 2/5 P. Excuse me, I have a typo here. This shouldn't be Q, this should be P. Negative 2/5 times P to the negative 7/5. Right, this negative 2/5 drops down and I subtract 1 from it, and negative 2/5 minus 1 is negative 7/5. Okay, so let's go ahead and simplify this out a bit. So this becomes negative 10,000 divided by 5 P to the negative 7/5. And that becomes negative 2,000 P to the negative 7/5. And then just for calculation purposes, I'm going to bring this guy back down and make it a positive exponent. So it should be P to the 7/5 on the bottom. So negative 2,000 over P to the 7/5. So that's my Q prime. Okay, so as opposed to the last question, right? We did a Q prime, we got a numerical answer, and that was pretty much it. Right, we were able to use that. But this time we don't have a numerical value. We still have that variable P in here. So what I need to do now is just plug in this P equals 32 into this derivative and get a numerical value that I can use in the point elasticity formula. Okay, because it needs to be a number. So what I'm going to do now is evaluate Q prime at P equals 32. Okay, so I'm going to plug 32 into this guy. So I'll say Q prime of 32 equals negative 2,000 over 32 to the 7/5. Okay, so then 32 to the 7/5, just plug that into your calculator and you should get 128. Okay, so if you do this calculation, you would end up with negative 15.625. Okay, so after this, right, this is our Q prime that we put into the formula. So last part here, now find point elasticity, right? Remember, it's epsilon equals negative P over Q times Q prime. So this equals P. P is 32. Q is 1,250. So this is negative 32 over 1250 times negative 15.625. And that equals, you put it all together, 0.4. So epsilon equals 0.4. And that's our point elasticity. Okay, so that is part A, right? Kind of scroll up a bit. So part B is just, is it elastic, inelastic, or unit elastic? So I need to figure out what that is. So let me go ahead and make another page. And part B, right? 3B, we're talking about elastic, inelastic, unit elastic. So since our epsilon is equals 0.4, which is smaller than 1, then the demand is, what's it going to be? If it's less than 1, it's going to be inelastic. Okay. Demand is inelastic. Okay, great. So we found our point of elasticity is inelastic. So what does that mean in interpretation, right? Talking about a 1% increase in price, what's going to happen to the revenue? So what I'll say here is, since inelastic, if the price is increased by 1%, right? That's what we're talking about. That means the demand will decrease by that percentage that we found, or that point elasticity that we found in percentage form. So it will decrease by 0.04%, which is pretty small. But this means the revenue, what's it going to do? If it's inelastic, the revenue increases with price increase. So our revenue is going to be increasing. Okay, so that is an interpretation of an inelastic demand. But that's it for this video. Please take it step by step. It's always the same process. Find Q, take a derivative, find Q prime, plug it all in, determine if it's elastic, inelastic, or unit elastic, and some type of interpretation if you're asked. But this is just really what we're doing. But that's it for this video. I'll see you next time. Thank you. Bye.